My name is Ilya Benish, and I'm a building analyst for the Cold Climate Housing Research Center here in Fairbanks, Alaska, Climate Zone 8. And this video is part 4 in a 5-part series involving a cabin energy retrofit on the outskirts of Fairbanks. And the brief backstory here is this cabin changed ownership while it was under construction, and the new owner looked at how things had been built to this point and wanted to engage in some energy upgrades. In this video, we're going to take a hard look at the existing floor systems and some improvements we can make. What we have here is a raised floor system that's actually very common to houses in Alaska, particularly in rural areas where we don't have access to concrete or much of the state has unstable soils. The end result is you have a floor system that's above the ground. Cold air circulates underneath. In this case, it's a very traditionally framed wood floor. It's got 3/4 tongue and groove subfloor. It's got 2x10 joists, and then underneath here is a built-up 2x10 beam that's carrying the weight of the structure. So right off the bat, assuming that fiberglass batts were used to insulate this floor, there's only about R30 in this floor system. And the state of Alaska, our energy codes recommend R38. In addition, the homeowner complained that at -30 in the wintertime, this floor was bitterly cold, like difficult to walk on in certain areas. And that's a chronic problem with floors like this. They have to be well insulated and well air sealed. So we know right off the bat, something here isn't working right. It's underperforming. And we're going to go underneath, remove the underfloor sheathing, and take a look at what we're dealing with. Oh boy. The first thing I notice here is that the installer, the original installer, didn't want to spend a lot of time under here, and that's reflected in how quickly this insulation was jammed into these joist bays. And this is really problematic. But before I go any further and address the insulation, I want to make the point that I am extremely suspicious of a floor I can't see. I'm not going to do any improvements to the underside of the floor until I know what the existing insulation looks like. You get situations like this where the insulation was jammed up and there's big air spaces and it looks like he was running out of insulation but none of this is doing this floor any favors. And if we added more insulation on the bottom, all of this airspace here would short circuit any R value we add underneath and could largely negate our efforts. Air leakage kills floor performance like this. When you're using fibrous insulations, it doesn't matter if it's fiberglass batts or blown-in cellulose or rock wool, all fibrous insulations work by trapping still air in the tiny fiber matrices that are in here. It's that still air that resists the heat flow through the floor system. As soon as you start introducing voids like this or air leakage all along the seams at the underfloor sheathing or around the perimeter, suddenly your energy performance in this floor really suffers. So it's absolutely critical that these joist bays are filled with insulation, full contact on all sides, especially against the underfloor, against the subfloor, and then everything is really well air sealed. And the last point I want to make is, there's a lot of framing in here. These are 2x10s doubled up. Every single joist I see here is doubled up, probably due to the span. There's rollover blocking. So even if it's perfectly installed, you've got R30 here, but where you've got a joist, your wood is probably R9 on a good day. What that means in wintertime is the heat losses through thermal bridging everywhere you have these joists on the floor. When you're walking around, yeah, these are going to feel really, really cold. And the way to fix this is to add 2 inches of foam board across the bottoms of the joists. So we're going to remove this underfloor sheathing, repair this insulation, add more insulation as needed. We're going to add an additional layer of R13 in here in most of these bays. Then we're going to add this 2-inch foam board, and suddenly we've stopped most of the heat losses through thermal bridging, and that homogenizes how this floor feels on the inside in wintertime. Our first order of business in addressing the thermal performance improvements in the floor is to take all the underfloor sheathing off and repair and add to the existing fiberglass insulation. And I'm seeing idiosyncrasies here where the installer put in little scrappy pieces. Some of this insulation is kind of dirty. I'm wondering if it's recycled. It's actually cut and fitted reasonably well, so I don't have to do a lot there, but I definitely have to tune the bats up so they're not bunched up here on the edges. But even when I do that, I'm not fully able to fill this bay. And this is a really important detail, whether it's new construction or whether it's retrofit work like this, it's okay to overfill this bay. It's far better to add a little more insulation, like I'm doing here. I'm adding an R13 bat after I've repaired the existing insulation. Now I have a continuous R13 bat, and you'll notice it's hanging down a little bit. But when I put my underfloor sheathing or my foam board on here, it's going to compress this insulation and it will remain tight, fully filling this bay, but tight to the subfloor. I will never have any undesirable air gaps between my subfloor and my insulation. So that's step number one. In new construction, same thing. If there's any danger that gravity is going to take an underfilling bat and create that gap in the subfloor, add another R11 or R13 fiberglass. You'll get that R38 or R30 to actually perform at its rated R value, and that's well worth doing in raised floors like this. I've got my starting course here of underfloor foam on. It's 2-inch foam. And the issue here is you'll notice I did not split my foam on a joist. I'm actually keeping my foam out here in the middle of the joist bay. That way I don't have a conductive path going all the way through the foam and through the joist. So it's just a small performance improvement. This is kind of an unusual situation because, as you noticed earlier, the entire underside of the floor is sheathed in 7/16 OSB, and my preference for protecting this foam and for air sealing is to have a layer of 1/2-inch CDX plywood under here rather than OSB, and there's several reasons for this. For one, a broader variety of tapes can stick to plywood, and the other issue is I don't know that this environment under here long-term is great for OSB, but in this case, what we've got to work with is OSB, so that's what we're going with. Consequently, I'm going to treat my foam board as my air barrier. So I've chosen an Artec EPS foam board that has facers, and my reason for choosing these facers is that I've got several tapes here, 3M 8067 and 3M 8087. I can get both of these at my local lumber yard, and I think that they should stick to this foam just fine to provide the air seal. At the perimeter, I've left a 1/4-inch gap between my foam board and my beams, and then I've got this minimal expanding foam. I've got a brass tip nozzle on my gun, and so I can inject foam all the way along up in here and get that air sealed, and I will go back, trim this off when it's hardened, and then in addition caulk over that foam joint for a durable long-term seal. The reason I've left the gap is that this foam board, things are never truly square, and so I find it's better to leave an intentional gap of a minimum of a 1/4 inch everywhere the foam intersects the perimeter beams, so I can get that area filled up completely with spray foam to get a good air seal. And remember, we're on potentially unstable soils. This structure can move. And so in this particular case, where our foam is now our air barrier, I'm also going to go along here with this Barabond caulking, and I've trimmed my foam away, And I'm just going to tool in a bead all the way along the perimeter. And this, in theory, provides a little more flexibility and long-term air seal on this underfloor area. And as I said, normally my underfloor plywood sheathing would be my air barrier. So I'm actually doing this for the first time too, but this belt and suspenders approach to air sealing at the perimeter is fairly easy for me to do. And so I've got 2 layers of air sealing protection here. For this project, I'm using 3M 8067 flashing tape. I can buy it locally. It works great in cold weather. It consistently does well in tape tests. And I'm going with the 4-inch wide version because I've noticed here in the foam there is edge damage, and I want to cover this seam, you know, a good couple inches on each side. And this tape, it's got some stretch to it, which is nice. So I can straighten it out and then bed it. And I'll just have to lay down here to get this, but you know, this helps ensure that it goes on nice and straight. And it is pressure sensitive, so ideally you'll want to go back over this with a rubber J roller, or just do a really good job bedding this tape by hand. But I have a lot of confidence that this will be a good long-term air seal here. When I put this OSB up, I'm going to stagger all of my seams in my OSB underfloor sheeting so that none of them line up with any of the seams in the foam. And I'm going to use at least 5 screws per joist because I want this OSB nice and tight to the foam so that there's no other air gaps, and that we're helping support this tape here. That will help ensure that this floor stays nice and airtight for the life of the house. I took a lot of care when I installed the foam board to lay out the center lines of all my joists on the foam board. So now I know exactly where my joists are and where they split. So things are pretty easy to keep track of, and it's easy to hit things with the screws. While applying underfloor sheathing to protect foam board in cases like this, it's a pretty generic way of doing things, and it works in a lot of cases. It's by no means the only way to do this. There may be even circumstances where you're in a forest fire danger zone, or you're in a wind-driven rain climate where the underfloor sheathing might actually get wet. Then other products like metal paneling might be a better choice. At the end of the day, what really matters is that we've taken this floor system and we've boosted the energy performance, we've repaired the existing insulation, and we've added that thermal break and made the floor airtight. And that's going to make a tremendous difference in how this floor feels in wintertime. And as always, we welcome your comments, your feedback, and your personal experiences with situations like this. And we will be posting additional links to information in the description. Thanks for watching.